What's going on, guys? I wanted to film a video on how to troubleshoot variable frequency drives. I'll point out a couple things on the schematic first. I'm going to be using, in order to troubleshoot, just a Fluke 87.5, and the reason I use this for VFD troubleshooting is it's got a low pass filter, and it's also got all the rest of the normal stuff like diode test and voltage that you need to frequency that you need to test a VFD with. Now, the reason the low pass filter is important is when you're running your AC signal through your VFD to your motor, you're getting, after the signal, the electrons go through the IGBTs, you get a reflection of the harmonic waves or something like that. But basically, it tricks your multimeter if you don't have a low pass filter into reading like 20 or 30% higher on your voltage, and it'll actually read the frequency of the reflections and harmonics from your rectifier. So the low pass filter, basically is super important to get accurate readings. The one thing that's confusing, because there's not a lot of information on YouTube on how to diagnose these things. There's people that show you what to do, but nobody says why. If you look at the schematic, we've obviously got a IGBT, or not a rectifying bridge, and then here we've got IGBTs, but these right here, there's one diode on each IGBT going in the opposite direction of the actual current flow, and these are called flyback diodes. Flyback diodes are used on IGBTs when your IGBTs are feeding an inductive load. So induction motor, induction load, you need a flyback diode, and the reason for that is if you don't have a flyback diode, you'll get these crazy high voltage spikes, and you'll basically fry everything. So we'll be testing these diodes, voltage, and some other stuff. So we'll pan over to the VFD we're going to look at today and go from there. Alright, so just keep in mind that most VFDs are feeding three-phase power. A good majority of them are fed by three-phase power. So, sketch factor sort of over 9,000. We're just going to take this plate off so we can get at the contacts. Alright. And I'm going to grab some gloves and PPE before I open up this little... Okay, sorry for the weird angle view, but it's the best I can do with being able to hang my voltmeter somewhere where you guys can see it, and also where I can get to these contacts. But okay, so we've got our voltmeter in volts AC. We're going to check our line coming in just to verify that the VFD is getting proper power. So we should have 480 volts between phases. This is L1 and L2, 480, L1 and L3, 480, L2 and L3, 480. That's perfect. So we've got good power coming into the VFD. Now we'll check our DC bus. So we'll put our voltmeter into volts DC. We should be reading on our DC bus 680 volts. Because you've got three sets of voltage potential between your L1 and L2 and L3. Your peak voltage will be between those three phases. That should all be 680 volts peak. It'll be like 480 volts times square root 2. So if our DC bus is at 680 volts roughly, that means that our bridge rectifier is probably working okay. So we'll go DC minus to DC positive. We've got 684 volts up there, which is perfect. One of the cool things you can do if you don't have access to your DC bus, it'll be labeled DC minus and DC positive. You can actually use just a regular multimeter that has a peak value, and what you'll do is you'll turn your meter into volts AC, and you have to do this with the VFD running, I would assume, let me see. Yeah, so you'd go terminal 1 to terminal 2 and then hit your min-max. On this meter you hit min-max and then you hit peak. Yeah, see, we've got our VFD off and our whole PLC system shut down for the weekend, so we're not going to get a reading. But if you measure your peak voltage on your terminal 1 to terminal 2 or 2 to 3 or 1 to 3, you should be getting as your peak voltage 680 volts. Even if your VFD says it's only outputting 240 volts at 30 hertz, you're still going to be getting the reflections and harmonics back from your rectifier. So you will be able to read 680 volts on your output side. Again, peak voltage. So the next thing you can do for checking is turn your meter to volts. On the 87.5, we'll put our terminal 1 to terminal 2 and check our voltage output. Now we need to use our low pass filter for this. So we engage our low pass filter. If this VFD up here said it was running at 240 volts, we should see 240 volts on our multimeter with the low pass filter engaged. And then the other thing we can do is go from output to output, so T1 to T2, 1 to 3, or 2 to 3, and check our frequency. You also need to use a low pass filter to check your frequency, otherwise it'll be reading all of your pulses and it'll say something ridiculous like 20,000 hertz, even though your VFD is actually running at 30 hertz or 35 hertz or whatever. So you need to stick in on the Fluke 87.5, you go into volts, you take your voltage reading on your VFD, and then you hit your low pass filter. So you've got your low pass voltage reading, and then you hit your frequency button, and that'll pull up your frequency through the low pass filter, giving you the accurate reading of what the VFD is trying to give your motor. Next we're going to get into diode testing, and I'll show you guys how we do that here in a sec. Oh, I got electrician's gloves on. Fuck these things. Like impossible to take off. Alright, I've got power off completely to the VFD, so all the power shut off. Now we're going to test our diodes. So we're going to test these top diodes first. So and you got to remember that schematics and your voltmeter uses conventional voltage. So if you study physics, you'll understand that your negative charge actually is the flow of electrons, and then your positive charge is where your electrons are flowing to. But the way multimeters and schematics are, they're in reverse basically. When Benjamin Franklin was flying his kite, he had a 50-50 shot at getting the polarity right on electrons, and he fucked up. So here we are, bass backwards on stuff like this. But what we're gonna do, your red electrode on your multimeter has actually got the power, and your black one is looking for power. So think of this as your pixie stick and as your search instrument. We're going to put our meter into diodes, and we'll put our positive lead on L1, L2, and L3, and we'll have our negative on the DC bus positive, looking for voltage or looking for a good diode. So, one sec here, I'll flip my meter into diode. What did I say I was going to do? L1, the DC bus positive. We've got 4.5 or 0.4, yep, that's fine. 0.4, these numbers should all be the same. All right, that's all good. Now we're gonna flip these electrodes around. So we'll be trying to send, pixies back this way. And if these diodes are working properly, they're basically electron check valves, so you shouldn't be able to get electrons through your diodes back that way. So we're going to put our positive lead here and our negative lead here, and we should get over limit on our multimeter. So positive on your DC bus positive, and L1 with your black electrode, L2, L3, and we're over limit on all three of those, which is perfect. I'll just mention real quick, one thing that was confusing when I was learning about this stuff is that your capacitor won't let DC current through. Even though it's a smoothing capacitor for DC current, your multimeter isn't going to be able to push anything through this capacitor, so you can basically ignore it as a non-existent feature when we're doing voltage or diode tests. So next thing we're going to do is we'll take our positive probe and put it on our DC bus negative, and we'll put our black probe on L1, L2, and L3, and we'll be checking these bottom 3 diodes here, and then we'll do it in reverse just to make sure that we don't get electron flow back the other way. So positive multimeter on DC bus negative, we should see like 0.4 here as well. Yep, 0.4, 0.4, 0.4, 0.399. Yeah, that's fine. Now we'll flip our electrodes around just to make sure that our check valves are working properly. So negative terminal on your DC bus and negative probe on it, and positive probe to your L1, L2, and L3, and we've got open line, which is good. Next we'll check our flyback diodes. We'll check these top 3 first, so we'll put our positive lead on our 3 outputs, and we'll put our negative lead on our DC bus positive, and we should get a similar reading. So positive on your negative on your DC bus positive, and then your 3 outputs, 0.32, 0.33, 0.329. That's perfect. So our diodes are working in the one direction. Now we'll flip this around. Positive on your DC bus positive, negative on your outputs. Over limit, over limit, over limit. That's perfect. Now we will check our bottom 3 diodes. So we'll put our DC or our positive probe on DC bus negative, and put our negative on our negative probe on the outputs. So positive probe on DC bus negative, and negative probe on our outputs, 0.32, 0.33, 0.33. That's perfect. Let's check them going the other way. We shouldn't see anything here. So negative on DC bus negative and positive on your 3 outputs. And we're over limit on all 3. And that's perfect. That means that all of our diodes, we've just gone through every single diode on this VFD, at least the main ones, and they've all checked out properly. So just to review for you guys, you're going to want your line-to-line voltage on your incoming side, 480 volts. Your DC bus voltage, 680. Your output voltage peak without a low pass filter, just raw peak voltage on your output should be about 680. Your output frequency should match whatever your VFD reads. You know, it's got a readout up here. So whatever your VFD reads out should match your frequency. Again, your frequency reading must be taken with your low pass filter. And then your output voltage should match the VFD as well, and that'll again be with a low pass filter. Probably should have started the video off with saying I don't have any formal training on this. I've just done a lot of reading on the internet, so I'm pretty sure what I'm doing here is correct and proper. But if you guys have any suggestions for me on what I'm doing wrong or things, other checks I could do, please let me know. Another thing to consider is if you're aware of how your VFD is receiving a signal to run at whatever speed, like let's say for example you are modulating your frequency on your variable frequency drive, you're auto tuning it using a PLC or a potentiometer on a switch somewhere. Let's say you're using a 4 to 20 or 4 to 20 milliamp signal. You should be able to look for that up here on your control module somewhere. Or if you're using 110 volt or a variable voltage signal, whatever. Like you can use a 0 to 10 volt signal or whatever. But you should be able to get those readings up there. That's super dependent on how you have your whole system set up. And I probably couldn't help you with that. So again, if I have it fucked up anywhere, let me know. And I hope this was helpful. Thanks for watching, guys.